Okay, this is Old Electronics Fan, and this is part 4 of the R35 Victor / RCA Victor radio. It appears that Victor was a Canadian company. I haven't explored it much further, but that's what I'm hearing. That's what I'm reading. So it's very possible. Oh, I noticed a little tear right there I missed. But I wanted to see how this looked, and just pushing on it gently to see how that's holding up. I think I can press on it from behind. It doesn't misbehave. It's flexible. I'm pretty happy with that. And the thing I didn't dare do before was check to see if this thing moved or not. And it does. I can't tell. It's a possibility that cone is rubbing a little bit, but I can't tell for sure. Well, we'll have to see. So, yeah, whatever this is. When I flip this around, I'm going to show you what the back of this surround looks like. In fact, I think that's what I'm going to do now. Oh, is there a way? I think I'm going to put a piece of cardboard on this, maybe tape it in place, because now that I've got it repaired, I like it to stay that way. Hold on. Alright, my protection is in place. Flip this around, and we will see what we can see. Now, the question is, which way do I want to do this? I'm going to do it like this. I should probably get rid of this dead power cord. It's, I think I showed you this. I don't, let's just say I don't have high regard for whoever did this. This was done quite a while ago. This is friction tape. A lot of people won't even know what that is. It's kind of like electrical tape, the vinyl tape we have today, but it's well, it's kind of messy. It gets hard. Well, I guess all tapes do over time get hard when they age. But this, I don't understand. I don't know. All right. Well, what I'm going to do, I guess, let's chop off that mess on the end there. Let's see. Well, yeah, that's not good either. Let's see. You know what? I'm just going to cut it off way further, because none of this is any good. So, get this out of my way. Put it over there for now. Now, and this is the on-off switch, and the wiring is not healthy either, so I'll have to do something about that, I guess. So, at some point, I'm going to take these tubes out, just because I want to flip it on its back, and I don't want the tubes being forced out of their sockets. Oh, there we go. Alright, I put that the wrong way. Come on. There we go. Boy, there's so much weight on this. Whatever's in that is flexing a bit. Alright, well, I want to take a look at a few things before I dig into checking this thing out. And one of the things I wanted to mention was, well, there's two things actually. I was puzzled a little bit about what they were doing with the volume control, because it's connected to the cathode of, let's see, yeah, it's connected to the cathodes of these tubes. So I was wondering why they were doing that, and some reading I did led me to think that what they're doing is they're changing or adjusting the bias to the cathodes, or to the cathode circuit, as one way of controlling the volume. Now, this is a dual control. If you look at the receiver part, you see the tone control, which is a single control, and then you see this one is a double control. And I was wondering where the other part of the control was. Well, I made a mistake. I made a mistake because I enlarged this, and then I forgot about that. And this is the full diagram. And out here on the antenna, put it down there and not make it move around too much. If I set it out here on the antenna, or if I look out here on the antenna, I see radio volume control. This is indeed a two-part control, a dual control. And so the other thing they're doing is they're controlling the signal level that's coming off the antenna. So they have two ways of controlling the volume. The cathode bias, and apparently they thought that wasn't enough, so they added controlling the volume of the antenna, or the signal from the antenna. The other thing, where was I headed? There was something else, and now I've forgotten what it was. Hopefully it will come back to me. Alright, so there was that. And I can't remember. Oh, this mess up here, this is when I was figuring out the resistor board on the receiver part of this unit. It got rather interesting. But, oh, I want to go through this rather quickly. Maybe I can't, maybe I should, yeah, I need it back out a little bit. Alright, this is the service manual for this radio, and I would really strongly recommend that if you're going to work on this, that you get this. It's a free download. I'm going to put the link into, I may have done it already, or I will do it in this video, and probably some previous videos will also have it, if I remember to do it. It's an amazing resource. World history is just a boatload of documentation and all kinds of interesting stuff. So, but anyway, this is the kind of information that you get in the service manual. In fact, let me take this off and let's look at that. So this is page 1. It's giving you an outline of the different things. That enabled me to realize that these could unscrew and I could get to them, which is very helpful. This one is particularly good, especially when you're working on the amplifier part, because this tells you where everything is, what's in each of these boxes, which is very helpful. And down here is speaker part list, amplifier speaker part list. It tells you that item 14 is the reactor. There's a couple of chokes in there. And then down here 15, power transformer. So that's, yeah, obviously that's the power transformer, duh. I just said what it was. And then over here they tell you that number 1 is the condenser bank. We'll be looking at that in a minute. Number 2 is the interstage output transformer. And I'll show you on the circuit diagram where a lot of this stuff is. This back here is number 4, terminal strip cover. This is where the umbilical cord goes between the radio and the amplifier. And then over here, right there, do they tell me? 13. Fuse cover. That's important. I'm going to go over that one shortly. And so, because that is important to know about. I found that one by accident, but I'll show you why why you need to look at that on if you have one of these. Let me try this again. The phone keeps ringing, interrupting me. All right. So up here, for some reason, and I haven't really checked into this much, if this unit has a phono in it, there are two wires that go from here up to the phono. This is one leg of the voice coil connection, and there's a little tie strap that you can loosen 2 screws, and you can put that little tie strip out, and then you can run wires up to your phono. Obviously, since this doesn't have one of those, that strap needs to be in place, shorting these two together. Let's see. I've been interrupted several times, so I don't know. I think I mentioned this before I got cut off. This is the fuse for this radio, and I'll show you why that's important shortly. I think that's all I want to show you on this. This is such a huge resource. Because, you know, this is the radio part, and it tells you, oh yeah, this is important too. It tells you, these are the capacitor blocks. Let me put this down here so it's not moving around. There are capacitor blocks in here. There's one there, one there, one there, and one there. And it tells you what capacitors are in each of those boxes. If you go down through the list here, it's very handy. This one got me. And, alright, this is a Weston 247 radio set tester, and some of the information they provide are done using this unit, and it uses a 10-volt battery, and I think, yes, okay, and so the voltages that you see in some of these charts are not useful because they're using this thing, and I got fooled by that. And let me just go to the section where I got into trouble. And there's a boatload of information that they do show you. Test across there's a constant, okay. And there's a bunch of things that helpful information. It tells you what the voltages should be. Well, this is the amplifier terminals. So they show you what voltages should be if you're measuring from certain pins to certain other pins, which is very helpful. Down here, there is these are the different different voltages, filament, plate, control grid, screen grid, and they tell you what the voltages should be on which tubes. And they give you some information on the lack of voltage and what that means. Then, let's see, I want to go to, okay, so this is the one that got me in trouble. So again, amplifier tube socket test, it tells you what the voltages are for the filament, plate, and grid for each item. Normal voltage. Grid here is 37 volts on the 45s, I believe, yes, which is pretty high, but I would have expected 9 at minus 37. We'll have to see what that is. Let's see, again, troubleshooting information. There's a board in the middle of this, which you can't see because I'm covering it, but it's behind here. There's this terminal board. There are no numbers on the terminal board. The only way you know what they are is if you have this sheet. This is the tube, I believe it's the 80 tube down at the bottom. This is the underside of the terminal strip, which is on the left end of the chassis, which you'll see shortly. Condenser bank, it's showing it well, I have this lying on its back with the speaker facing up. This is the orientation if it's the opposite way down with the speaker facing downward. Because these numbers are at the top, so pin 5 is up the top. This is the edge of the chassis right here, and pin 1 is down toward the middle. But here's what got me into trouble. Let me go down to, well, meter used 10 volt scale of Weston test box 547. I had not read that. One of the guys I talked to who knows radios really well, has worked on them for 30 years or so, he pointed this out and he says, you know, these voltages don't mean anything because they're using this Weston test gadget. And here's, well, I was looking at these voltages across the various coils. For instance, the plate choke, 6,000 ohms, but it says 4 volts. That made 0 sense to me. And I'm getting to that a little bit deeper because I spent a whole lot of time on this off camera, and be glad that I did because you'd been bored out of your mind. But anyway, so that's one thing that will bite you right here. These voltages are useless because of what they're using there. And then you've got this one. This has the Electrola, which is the turntable, and it says recording parts. Microphone. Apparently you can record. There was something you could record with on this. I have no clue. But over here you see again the condenser bank. It shows you the power transformer and what voltages are supposed to be where. I did check this off camera, and all the voltages for the power transformer are good. Down here you've got the internal connections of the power transformer. I'm sorry, down here you got the internal connections of the interstage and output transformer, and it tells you, it gives you color codes and what each of the color codes is for. It is very difficult because the color codes, the wires have faded, so it's hard to pin down what's what, and I'll show you how I wound up doing it. It's a whole lot easier than trying to guess what the color codes are. This is for the receiver, and I used this a lot to figure out what was where on the resistor board in the receiver, and there's another board also in the receiver. So as you can see, there's a bunch of information, and then you've got this, which gives you again more information. And this one, actually, this is important, and I think, is this the last one? Alright, I'm just going to show you this one very briefly. This is also handy. Top view of an amplifier terminal strip, and it tells you, again, it gives you color codes which are less than helpful, because again, the wires are not in very good shape. But it tells you the order of the wires that connect to this, and it tells you what the color codes are supposed to be, and unfortunately on this radio they aren't helpful. But if you notice, pin 5 has nothing connected to it. It's got a wire connected here, but there's nothing coming from the umbilical cord, which is here. And so you can actually use, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4. Alright. So you can figure out what the orientation is, because 5, if you look at the wiring here, there's going to be no wire on 5, so you can actually count to see where the gap shows up. So you should have 4 wires here and 3 wires here. That tells you the orientation if there's any question. So that's very helpful. And again, there's a whole bunch of information that I haven't read in here. And this one I think is a duplication of what I was just showing you. And is this the larger one? No. This is the one I want to show you. Alright. Let's look at this. Alright. Now, I want you to notice something. This is what confused me. Let me go up here. All right. Look at this one. All right. This is all brown. It's got an end color. It's gray. There's no dot on this. Look at this one. It's got a red on the end of the body. It's got a green body, and that's it. There's no dot. And if you go down here to this one, let's go back down here. This is why it gets even more confusing. If you look at this, and then you go back up here to this, what you're going to notice is there's a metal cover here that looks gray, but it's just the metal that's shown through. Who knows how, but the paint is gone. And so when you glance at this and think, oh, well, that's just this metal showing through. Well, it's not. This is actually a color that they put on this resistor. And it does mean something. If you go over here, and then there's actually another resistor, which, do I have that floating around? Yes, I do. I'll show you this one. Let me just let me get some more light on it, because that seems to be dark. All right. Okay. So we look at this, and the brown is sort of scraped off, so there's some black peeking through. But you can see the metal peeking through there, and sometimes that's all you see. The paint is gone. This has a brown dab on the end. This, I think, is supposed to be, what is it supposed to be? I can't remember now. The color code doesn't mean much, and I don't see this one listed here. But let's go. So let's look at this. Let's see. This one I believe came out of my the receiver part of this. And I don't know if there's documentation that tells me what this is, but here's where it gets rather weird, because look at this. 8K brown with a gray end. 8K brown with gray end. That does not help us. Using body and dot, you would never come up with that. Brown is 1, gray is 8. So, I mean, gray is 8, so, and it's 8K, so maybe that has something to do with it. This one, however, is the one with the this green with the red end. Well, red is 2, green is 5. Yet it's a 70K ohm resistor. So these are resistors that you don't know the values without some kind of a chart to tell you. And I gotta go look and see if I can find I'm curious, find the one that tells you with that brown with dark brown on it. The receiver, there are at least 2 resistors that were put on that, which were not factory, and I think they were, whoever did it didn't know what they were doing. So that resistor I just showed you might be one of those that got stuck on there and didn't belong. So just be aware that some of these old resistors aren't body and dot. They're just an arbitrary color code that you need to know what they mean. And there's probably a resource somewhere, and I haven't looked for it, but there's probably a resource somewhere that tells you what the different color combinations were for, or what they meant. So anyway, there's that. So now, let me go back to this, because I want to show you something. Because I tore my hair out trying to figure out where the wires went, and all right. And it was driving me crazy, because I was struggling. I did plug this in, and I did just get voltage readings off from the power transformer, and I've determined that the power transformer is fine. Now, what we've got is we've got L16, which I believe this one is. That's connected to the capacitor box, but this is over in the reactor box that I showed you earlier. This is the field coil. This is on the speaker itself, of course. Over here we have L15, which is another coil, another choke. Both of these are chokes, and this is actually being treated as a choke. And actually, let me explain a little bit about these early radios. 2 microfarad, 2 microfarad, 1, 2 microfarad. Tiny microfarad capacitors. And I talked to somebody about that, and he said, back when this was built, making large capacitors was difficult for them, and these are not electrolytic. You could probably use electrolytic here, but these are not. These are paper caps. So I was wondering about that because of their size. And sure enough, that's what those are. And over here there's a 0.2. That's a bypass cap, and that's also in that capacitor box. Actually, let me show you the capacitor box, which is right. Let me back out a little bit. Alright. Now, there's that number that you see up here on top, which they show you, which they were showing you it oriented the other way, because I have this, like I said, speaker up instead of speaker down. The numbers go 1, 2, 3, 4, 5, 6, 7, 8. So, what I finally did is, because they tell me, let's go back to the schematic again. Alright. They tell me what the capacitors are that are in the capacitor box, and tell me what numbers they are. Now, I can find out what goes where by using one of those sheets that I was just showing you. And let's go to this. Alright. Now I got my sheets all out of order. Okay. This tells you what capacitors are where. It tells you that C28 goes from 8 to 5, and 8 is common, or ground. And so it shows you all the capacitors and what numbers they're connected to. So I was able to use that, and then I went to here, and I marked on my schematic what connections were, and I put 8 here, but actually this is also 8. So I remarked it there so I wouldn't confuse myself. Pin 7, pin 1, and this is pin 2 from the capacitor box. And you notice this one is separate from the others. This one doesn't connect to ground inside the box. These two terminals are only connected to from outside the capacitor box, as you may have spotted when I was showing you. So, alright, so I've confirmed that this is healthy, but I've got to make sure that this, and this is healthy. So, now that I know, finally, where everything is, and move this out of the way, we're going to come back over here, I'm going to turn this on, and we are going to, I think, we're going to zip out a little bit. Let's slide you over, and I'm on the wrong section of the amp. That's why I wasn't getting very far. Alright, now, remember that 1, 2, 3, 4, 5, 6, 7, 8. That's how things are organized. So if I go to my schematic, How about schematic? Yeah, that too. Alright. So I look at my schematic, and I go back here, we'll go down, right here. So the first one goes pins 4 and 3. So let's go back here, and pin 4 and 3. Alright, so 1, 2, 3, 4. Alright, so now I'm checking this with everything in circuit. When you're measuring resistances and you still have things in circuit, you can get away with it sometimes. What you will know, that you have to disconnect something to get a more accurate reading when the reading you're getting is lower than what you're expecting. So this, and I've already looked at these numbers, and this says 328, and that I believe is correct. So that coil is healthy. Next we gotta go from pin 3 to pin 8. 8's down here. This is pin 3. 1300. I think that one's supposed to be 1400, thereabouts. But the coil is there. If the coil weren't there, all I would be reading would be the capacitance of that connection and not the resistance of the coil. And so now I've done, so that's my field coil that I just measured. And now I want to go to L18, that's pin 8 and pin 7, which is this one and this one. And notice something. All I'm reading, that's capacitors that I'm reading right there. I'm reading nothing. So, now what do? Alright, so it's telling me pin 7 goes up to 7 on the schematic. Bring this back for a minute. Alright, so if I go to, oops. Alright, so pin 7 of this goes up here to pin 7 of the terminal strip that goes up to the umbilical cord. Let's see. What it doesn't tell you. Okay, remember I was telling you about the reactor box? Alright, so let's boundary resistor. I gotta find what I want to find. I'm not sure if I'm finding what I want to find. Alright, so let's go back here for a minute. What I need to know is where the reactor box lives, and that should be 14. And since that's with the speaker down, with the speaker up, is that right? That's 2. Interstage output transformer. 1 is the condenser bank. Oh, that's right, because it's from the top. Okay, this is where you can get confused. This is looking down on the top. So if you're looking at the, hang on. If you're looking at the bottom of this, all right. So number 2 is interstage. Number 1 is the condenser bank. Alright, so there's my condenser bank. We were just on that. These are the tubes. And in order to get this to be right, I'd have to flip this way, which is very confusing. But now that I know that these are inverted, because my capacitor bank is over here, but it's up here, not down there. I go over here. Now these two boxes are inverted because it says the reactor is up. But because I've got everything flipped, the reactor is actually down here. So, and these are the things that will get you in trouble when you're using these resources. They're very helpful, but you can get in trouble if you get things backwards. Because I did that several times before I realized, oh yeah, this is not the way I think it is. Alright, let's see if we can get some more light on here. Maybe? Yeah, alright, we'll try that. Okay, as I mentioned before, there are no numbers on this, but I'm not going to worry about the numbers because I have these to work with. So I know that. All right. So we've got these two. This one I already know. Let me go here. One of these, in fact, let's put this over here, and I'm just going to put it on noise maker. All right. So I know that one of these. So if I go here, and I use this a lot, just trying to find things. So there we go. So this is the one. This is the one that goes to pin 7. But then the other one goes over here to this reactor box. Whoops. Well, I guess I kind of wanted to do that anyway. Alright, so now if I go over here, and I've got these wires coming out of the reactor, and I see a pair of them. So I have 5 wires coming out of here. These all seem similar in color code. Therefore, I think these two, which are the same color code basically, these have probably got to be the L18 coil that I'm looking for. So let's see. Okay, so there's one side. If I go here, all right. So that means I know that means that I've got this correct. These 2 wires are indeed the ones that go to that L18 coil. Now I've unsoldered this one because I wanted to be sure that I wasn't making a mistake. So when I know that this came off the top and we go to the bottom, alright, let's see. And nothing. Is that right? Did I get the right one? Pay attention. Yes, right there. So that's the one, this is the one, and that coil is definitely open. So what do I do with that? Well, I go back to our documentation, because I've got to find out what that is, and I just showed you that this tells me what I want to know. That L18 is, and they don't, alright, so here's the way I found out, or figured out what I wanted to know. Alright. I was measuring between pins 8 and 7 right here. It shows you 7 and 8 of condenser bank. It tells you it's the plate choke. And then it goes over here. This is that bogus 4 volts. And this is 6 k ohms. That is a massive coil. I mean, it's huge. I thought about trying to recreate that and mount it somewhere else. I'd have to have another big box mounted on the back of this thing. That is huge. I'm just gobsmacked. They must have used fairly fine wire in order to fit that in there, fit that in the box it's in, because the box actually has 2 coils, one of which is has a center tap on it, and I'm not sure which one that one is. I haven't figured that out. But at this point, it doesn't matter because I've gotten all of the coils that that are important to me checked, and I did check these, and I was able to use pin 8 to check here, and then the plates here and here. I was able to check that coil using that, using the plates of the 45s, and then using pin 8 over on the capacitor box. So I was able to figure out that coil is fine. I was able to go to that little short on the back of the radio that I showed you earlier. I found that. I was able to use that, and then you go up here to ground, and you can measure from there to ground, and then you get And then you get, so I have now checked all of these coils, and this one is dead. So here's there's basically only two, well, maybe three options. Option number one, find a used coil that came out of an R35 Victor radio, RCA Victor it's sometimes called, and then replace that. You could, if you're insane, take the reactor box apart and see if you can find out what happened to that coil. Chances are you might have two transformers that are basically wrapped around each other, which means you run the risk of wrecking the other coil, whatever it is. So that's not a good idea. Third option, and this is the option that I am going to use, is to replace L18 with a 6K ohm resistor. Thankfully they gave me the resistance information for this coil, which allows me to, I know what the resistance is. If it weren't for that, I would have to do some experimenting, and usually chokes are not that big. That is just huge. But thankfully, like I said, they gave me the resistance, I've confirmed that coil is definitely dead. So what I'm going to do is I'm going to temporarily put in, I went digging through my stash of resistors. I've got a 1K and a 5K ohm 10 watt resistor that's going to go in there. Somebody I know has a huge collection of high wattage resistors. So if that resistor works and doesn't get too hot, which I'm hoping it doesn't, then I'll probably just go and hit him up for just a 6K ohm. So I can mount one resistor in place of this, and I'm going to mount it on the capacitor box. I'm going to mount it across these two connections here. Now this I've measured. This is supposed to be this is the 70K, which is R14 on the schematic, and this one is on pin 6 and 8, and that one is 8K. This one's reading 9.5K. This is also, well, this is quite likely 20% tolerance. So that means that this could be as much as 1.6K ohms out, or higher or lower than what it's supposed to be. So that means it could be 9.6K or it could be 7.4 and still be within tolerance. I'm opting to change this. This got cooked. This got cooked. This one's higher in value as well as this one. The one down here on this terminal strip, this one's actually 8K, like it's supposed to be. So this one's going to stay. So, so now the question arises, what am I going to do with this capacitor box? And I'm going to test this as is right now. And one of the things that I want to know for sure, one of the things I'm concerned about, is you've got that 0.2 capacitor that goes between here and here. And that goes, let's go back here, I'll show you. And we're going to go down here. Alright. Oops, we're on the wrong section. Let's go down to this. Alright. 0.2. This goes to pin 1, and then this goes to pin 2. And like I said, if you look at this, this chart over here, you can see that there are no internal connections other than the capacitor between these two pins. It doesn't go to a ground over here. So this capacitor is separate from all the others. Now, that 2 does not mean there's a connection between here and here. I put that too close. I should probably move it so I don't confuse myself. But this capacitor goes over here, goes down, and goes into this transformer. This is the interstage transformer, the phasing transformer, whatever you want to call it. And then the other leg goes up here and goes to pin 4, and it goes to the cathode of the 27 tube, which is up here. And this is, I think pin 6 goes to the plate. So one side of this goes to the plate of the 27 tube. The other side of this goes to the cathode of the 27 tube. And this is going to the plate. Okay, so this is a coupling cap. So it goes from the plate of the 27 tube, goes to the transformer, and then feeds the output tubes, the push-pull output tubes. So this is critically important. Okay, well, I'm inserting this here, and well, I've been misunderstanding things, and after looking more carefully at this circuit diagram, I decided that I'd try to get it right, I guess. The place where I got it wrong, well, let me back up. When I worked on electronics many years ago, 40, let me think, 50 years ago, between 40 and 50 years ago, my primary goal, which was often done without schematics, was to find out what was wrong and fix it and then move on. So I didn't spend a lot of time examining schematics, and of course after all that time I've forgotten a lot of things I knew back then. So I've had to go back and dig through instructional stuff like the naval training courses, and there's a lot of good information there. So it's helped me get back to where I was, maybe beyond where I was. And one of the things that I really like about this project has been the fact that it actually inspires me to dig deeper and to learn more things. And I have learned a bunch of stuff in the course of doing this radio. It's taken me a whole lot longer due to some of the things that were just simply outside of my control. It's taken me a whole lot longer to get this radio done. But at the same time, I think it was a good thing, because as I'm going back and reviewing the video that I shot quite a while ago, I'm realizing some things, some very important things, and I want to share those with you. And for those of you who are experts at this stuff, these will not be revelations to you. But for me, well, there were things that I missed, things I probably should have understood, because I have basic theory. I have a basic understanding of how tubes work. But there are certain things that are different about the way these old radios worked, and the way they did things compared to more modern stuff, more modern tube stuff. But let me get right to my point and get to this. This is what I thought was a coupling cap. Well, it is and it isn't. So let's look at this. This is the power supply. This is part of the filtering. This is part of filtering. This is filtering right here. Let's see, B plus. Do I have that marked? Yes, there's B plus. So 7 is B plus. And then over here we have the plate voltage for this tube. Now, my thought was that this was a coupling cap designed to protect the grids of these tubes. The only problem is, let me drop this down a little bit. The only problem is this. We have DC here. Actually, we have two things. We have the output of the plate of this tube, which of course is oscillating current, audio, frequency, whatever you want to call it, signal. But we also have a fixed DC voltage. Now, the reason I thought this was here was to protect these tubes from the DC voltage. That's not true. DC voltage cannot travel through a transformer from primary to secondary. It's not possible. The only time DC can do anything with regard to a transformer is when the voltage is just coming up. As the voltage comes and it increases and it travels through the transformer, the primary side, because this is a changing and increasing voltage, you will see something over here, a small amount for a very short moment. Once the DC voltage stabilizes, however, no more signal coming from the DC here. So that means that this transformer pretty effectively protects this from this. Once I realized that, once I thought this through, and as I looked at this more closely, I thought, well, okay, why have this here? Not because of this. So I followed this, and it goes up here, and it goes, and I've labeled this cathode, which is what it is. It goes up here. And you'll notice I have a resistor and a capacitor here. So, what this is doing is it's keeping the plate voltage, the B plus, from traveling up to the cathode. You really don't want your full plate voltage on your cathode. The plate voltage is a high positive voltage, and it's going to shut down the tube, because there are two ways you can make the bias of a tube work properly. You can make the grid more negative, you can make the cathode more positive, which means that the grid is negative relative to the cathode, which is what you want. However, if this becomes too strongly positive, this becomes correspondingly much more negative. That means that flow through this tube, current flow through this tube stops. If I have this right, because what happens is you have a heater, heats this cathode, sends off electrons which are negatively charged. They're trying to get to the plate. If your grid goes positive, then you're going to get a lot of flow through your plate, and if it gets positive enough, you will terminate your tube with a red plate. On the other hand, if the grid is negative relative to this, and if it's enough negative, it will prevent these electrons from traveling through the tube, because like repels like. So if this goes really high positive, and this as a result becomes really high negative, your tube is going to shut down. Bias is very important. So one of the things that you're looking for in a tube, there's something called the quiescent state, which is basically the tube sitting there idling, and the current flow through the tube is relatively low. That's what you want. So that when you get a signal in, the signal will then start current flowing through the tube, and the output will resemble the input. So now the plate has an oscillating signal, an audio signal, comes down here, over here, back here, and then here. Because this is an oscillating signal, you call it AC, oscillating DC, whatever you want to call it, it can travel across this, through the transformer and into the grid of these two tubes, and now these tubes can amplify the audio signal which they have just received. One of the hard things one of the things I've had a hard time wrapping my head around is how you can have a DC voltage, which is what this is, and an oscillating DC or oscillating AC voltage, whatever you want to call it, on the same wire. Now I do know with my head that these two voltages can exist on the same wire. It's just hard for me to really grasp fully. But that's the reality. You've got the B plus supplying this plate with the voltage it needs to operate, and then you have the current that's modulating this plate voltage, and so now it's duplicating the audio that you've just sent in. So anyway, so the purpose of this is to protect this, not this. Now, one of the other things that kind of confused me was that on a more modern radio, and it's not true of all of them exactly, but I think there has to be current flow that goes from the cathode through the plate and back around. If you look at some of the naval training courses, that's exactly what they show, that there's actually current flowing from the cathode through the grid, through the plate, and back around to the cathode. Well, that is what's happening here, because if you look at this is the plate, goes through the transformer, goes back up here, goes over here, and goes back up here and goes to the cathode. And then you've got the bypass cap and the resistor, which are designed to keep this bias stable, despite the fact that it's getting current flowing through it that's changing, that's varying, which is what it does get. So, anyway, I was worrying about this affecting this. And when I was measuring, I really, really, really wish I had paid more attention, I had realized what was really going on. I measured the grid voltage with the old cap and with the new cap, and I saw basically no difference, which is not surprising given what's here. It's because this is not going to affect this. What I wish I had done was check the voltage here with the old cap and with the new. There's a good chance I would have seen a difference there. I have no idea how much. Maybe it wouldn't be enough to say so, but when I measured this capacitor, it was around 20 megohms. And you might think, well, that's pretty high. That shouldn't affect anything. I've seen a capacitor that was leaky and had a measurable 20 megohm resistance using the BTVM. I actually saw one of these trash a tube because it was producing too much plus voltage to the grid, and the tube red plated and terminated. So I already know that a bad capacitor can be trouble. In this case, it might not have terminated the tube, it would probably have just shut it down, or if it didn't leak so badly, it would reduce the volume coming out of this tube, because this signal in the grid would have to be much higher than normal in order for it to overcome the more positive cathode. So you would lose some of your output, and depending on how bad it is, it might make your radio pretty quiet. So anyway, so that's the true purpose of that. My goal is to learn to pay more attention to my circuit diagram, especially things like this that are kind of important, and so I can better troubleshoot what I'm working on. Because if you can understand basic theory and beyond, and you can start really paying attention to the design of the circuit that you're working on, it can help you a great deal. So if I had noticed that this radio was playing quietly, I could do some voltage checks, I could do some signal tracing if necessary. But if I checked the voltage here, I might have realized that this was way off, and that this tube was not going to put out what it was supposed to. So it would have been very interesting. I wish I had. I don't think I have any old capacitors I could play with. Do I still have the old ones I took out? Probably not. I think I tossed those. Because it would have been nice. It would be nice if I still had the original capacitor. No, I think I got rid of it. Darn. The small capacitor was the bypass capacitor. That one I could actually still read the values from that. And I think I just got rid of it. It was messy, kind of nasty to keep around. So I think I got rid of it. Darn. Well, anyway. So, but I'm pretty sure about what I'm saying about this is the reality. A leaky capacitor here could affect this and could affect your output. So, it won't affect the bias for these guys. It's interesting that the, let's see. Yeah, and I think I may have in another video, I may have gone over what they were doing here, because you notice they don't have a capacitor here in this cathode circuit. All they have is these resistors, and there's a reason for that. And so I'm guessing that the bias is happening here, but because there's no capacitor there, it's allowed to fluctuate a little bit. And there are advantages and disadvantages to that, but I'm thinking that these are biased through this, which then the signal coming in is going to affect this. So anyway, I could wander far afield and I could get myself deep in a hole, and I'm going to stop right here. So I've been really interested in the thing. Well, I've really enjoyed the things I've learned doing this. Number one, I've never worked. My first old radio was the Atwater Kent. It was far less trouble to work on than this one is, and has been. This one has been much more challenging. I guess more interesting. I've learned a lot more working on this old radio than I did on the Atwater Kent. Thankfully, that one was in really good shape, and it didn't really require a lot to get that one going again. So this one, however, has been a different story. But that also means it was an opportunity for me to learn a lot about these 1930s radios. A lot of stuff I just did not know. Thankfully, I had a resource I could call on who was able to set me straight when I went off the rails a bit here and there. So yeah, so I'm going to bail out here. Hopefully, this helps others understand what I misunderstood. Yeah, this is still kind of important. And I was trying to think about whether or not I've had any paper caps short. And yes, they can, and they do. And I've actually seen other people's videos restoring radios where they found out that they shorted. I actually had a bumblebee capacitor that was trying to short out. It was running very, very hot. It was definitely a low ohm resistor, basically, which meant that the current flowing through it was too high, and the thing actually blew up. It actually split the plastic case and started leaking stuff out of it. It was kind of a mess. So yeah, so these can go bad. I don't know if these old ones have that tendency. Well, let me see. Actually, I think they probably do. I did measure these with my VTVM, and some of them were as low as 5 megs. That means that they were indeed deteriorating pretty badly. So I'm pretty sure some of them were that low. They weren't healthy, let's put it that way. So if they continue to age, they probably could ultimately short out. So that's bad. So anyway, I am ending this, and we'll go back to the video. You may see a sudden switch to something else, because I will probably kill everything else that just doesn't make sense now that I've looked at this and explained what's really going on and what I just flat out missed. So, anyway, hopefully that wasn't too crazy. I sometimes get off track. Oh, there's something else that I want to do. Because I remember I mentioned the resistor, or the fuse rather. Oh, man, you can't see squat. All right. There's a couple of holes in here, one here and one here. I'll flip the radio up so you can see what they are. This is where the fuse lives, and I found that kind of by accident. Well, there was a little box sitting on the back of this, and I don't know where I put that box. I keep misplacing that. Ah, here you are. It's a little box that was sitting on the back on top of the radio, and I didn't know what it was for. It says, "Caution, remove power supply before removing cover." Well, that was intriguing, so I decided to pop it off. And I'm glad I did because, well, let me show you on here first. And when I was looking at the documentation, it actually showed that box as one of the items that no, not that one. It showed that box as one of the items that was sitting on top of the radio, and it did identify as a fuse holder. But if you look here, let's zoom in again. You'll notice it says 120 volt fuse, or 120 volt fuse, and 110 volt. So let me show you. See how much of a pain this is going to be. I'll zoom you back out again. All right. Yeah. Now I have tubes. I have put tubes back in this because I did test the voltages on the plates and all that sort of thing. I'll take this one out for a minute. Okay, I got to tilt that so you can see. Can we do that? Yes, we can. All right. Now, let's see if we can zoom up. I want to show you. Yeah, there we go. Now you can see the 120 peeking out there. This fuse can be put in here, or it can be put in here. There's a connector right here, the center one, and then there's this one. This is for 110. 110. Hey, it's actually legible. And this is for the 120. When I took this apart, this is the other reason why it was important for me to check this out. Because there are two problems with this. This fuse is over here in the 110 side, which is not good. And moisture had gotten in here. Whoever had worked on this at one point, the cover was just sort of sitting on top. There's little tabs in the back that are supposed to go into tuck under the edge of the opening of the chassis here. And it was just sitting on top, which allowed moisture to get in there more readily than it would have. So this is all corroded. So I took the fuse out. I cleaned the center one. Actually, did I do anything with that one? No. I cleaned this, checked that one out, cleaned the end of the fuse, cleaned it up so that it would work. And then like my high quality connection, that's going away at some point. I'm going to try to order a fabric cord to put in here. So anyway, so why is this important? Well, this was built back when voltages were variable. Some areas would get 110, or they would regularly have low voltage. Some areas would have 120. So they gave you an option. If you happen to live in the areas that had the higher voltage, you change the fuse and you're good to go with the high voltage. If on the other hand you lived in low voltage, you can switch it over. Now, here's why this is important though. Remember that I said that tubes, especially the 45s, are very expensive? Well, if you have this hooked up to 110, but you're running on a 120 volt circuit, and some of us have 123 volts or so, you're going to be driving these tubes with much higher voltages. Well, I say much. It's going to be higher filament voltage than it would be if you had it on 120. So if you get one of these radios, you need to check and make sure that the fuse is in the right position, because you don't want to run it with the fuse in the wrong place, because it could shorten the life of your tubes. The filaments in your tubes could go away. You really don't want that. So I think I'm ready. I can put this back on since I'm done with you. Oh, and the other thing is, it's nice when you don't know about such things. You could have a lot of fun, especially if those fuses had corroded. The ends of the fuse had corroded enough that there either was a flaky connection for your power or no connection. I guess a little bit of tracing work would have revealed, I'm going to use this one as a bigger screwdriver. I guess a little bit of tracing, circuit tracing, would have probably enabled you to find it. But I'd rather find out things up front instead of to chase them and try to figure out what went wrong and why it's not working. I mean, I have that issue anyway, sometimes. But by checking things out in advance, you can avoid some of that. Alright, so I'm going to install, I've already gotten I should have done that first. There we go. So we're going to just tack on here. So I already dug these out. Get these ready to go. So I've already got this is my 6K ohm resistor. It's going to go there. Put that on. And alright. We'll do that, yeah. And yes, this is temporary. Because I'm really, really leaning toward pulling this capacitor box out and stuffing it. That's what I think I want to do. I just don't like the idea of I'm just kind of anxious about those old capacitors. And there's a possibility that those are going to be absolutely fine for a very long time. And I'm not gonna take this apart before I actually do some testing, because number one, I want to see how they behave. Are they humming? I want to check this guy out, make sure it's not overloading the grids. And for that one, I could temporarily just take a wire off and tie that together with a new capacitor, just temporary. So what's going to happen is one of these capacitors I'm going to wind up putting on the electrolytic capacitor. That's it. That's where I'm headed. The electrolytic capacitor that I'm going to use, I'm going to connect on the outside. I'm going to connect between here and here or here, which way that's supposed to be. I'll make sure I get it on the correct side. Because I just don't like the idea of having electrolytic inside the box. Especially if people who know about these radios believe that there's nothing but paper in here. I just think it's best to have it out where it can be serviced easily, or I don't want someone to have to pull the box apart to get to that electrolytic capacitor to service it. That would just be a royal pain and not necessary. And yes, it won't look original underneath, but it's probably not going to either, because all three of these are going to be modern. Okay, so, and I have, must confess that I have tested this. I'm getting B plus going out to pin 7 here. I had to put my 45 tubes in here in order to get voltages that were correct. Once I put these in, B plus voltage in general became closer to what it's supposed to be, which makes sense because now you've got it loaded down. Without the tubes, like I said, it's like 525 was the voltage, something like that. Something really high. Alright, so the next thing I'm going to do, as I'm wrapping up part 4, is I'm going to get, I've ordered resistors. I forgot to order capacitors for this. Ew. I don't have any 2 microfarad paper capacitors. I need to order those. I'm gonna put the new resistors. Well, I'll leave this here. I'm gonna put new resistors here when they come. I'll replace the resistors I need to on the receiver part. I'm gonna put these 2 together. I will make sure that the grid voltage gets tested first, and then we can see if this radio actually makes sound. So I hope I've given you some interesting information on this. Anyone who has one of these or something similar,